Hi, and welcome back to Algebra 1. Our goal for today is, can we expand expressions using what's called the distributive property? Or can we rewrite an expression in its simplest version using the distributive property to get there as opposed to some other method? So the thing that's going to help you today is just understanding what the word distribute means, because that's really what we're doing with our math as we go through the distributive property. So the word distribute means that we're going to take something and hand it out to everything else. So that's exactly what you're doing with your numbers when you do your distributive property. You're taking something and you're handing it out to everything else in the problem. So when we rewrite or expand using a distributive property, we always have to think is, I have to take one item and hand it out to the other items. So your rule would look something like this. Hit pause if you need to fill in your notes. All right, so the shortcut of the rule is, as long as I have a number that's directly touching, or it could be a variable, directly touching a grouping symbol, please remember that that's multiplication. So if I had something that looks like this, where I have some value, or maybe even a letter, it could be a variable, it could be a number, that's directly touching, it's directly touching our grouping here. Please remember that's the invisible operation of multiplication. So that 8 times something being added or subtracted in here. Right? So as long as we have individual things being added or subtracted on the inside, we can say that we could take this outside thing and multiply it with the individual items on the inside and get the same result as if we were just to do the add or subtract and then the multiply. So your distributive property says I can take that outside times item and multiply with the items on the inside, as long as the inside is an add or a subtract operation. And then once we do that, the parentheses will remove, and we can simplify any results that we get from that multiplication problem. That's the distributive property. And after you expand using the distributive property, we get what's called the expanded version. It no longer has grouping symbols or parentheses inside it. So we're taking this what's called factored version, and we're taking that outside number, the outside factor, and we're sharing it to the inside items to get the expanded version. That's our goal for today. All right, so last couple of days, we've been working with evaluating expressions. And when we saw this word evaluate, and we have what's called a numerical expression, like we have here, all that means is we're going to follow, please excuse my daring tell you, PEMDAS, or order of operations. So in this problem, we'd say, all right, we have a times here, and then we have these grouping symbols with add in it. So we would do this add portion first. We would do the 4 plus 2. We would have a 10, a times, and this is still a 6, or now becomes a 6 from doing the add. And then we'd say, all right, there's one more thing, which is a multiply, which would give us a 60. And that's what we've been doing for the last couple of weeks, evaluating until we get to one final number. Our goal for today is a second approach for that type of problem, which is instead of evaluating it, we want to expand using the distributive property. So expanding using the distributive property here would say, I have a number that's being multiplied, and on the inside I either have an add or a subtract. So the other approach I could do is take that outside item and distribute or hand it out to the items on the inside. Now remember, this is a 10 times when we hand it out to the items on the inside. So this would become a 10 times the 4, which would give us a 40. And then we'd have a 10 times this whole thing. I need to think of it as a positive 2 when I go to do my multiply. If that was a subtract, I would want to think of it as a minus 2 or a negative 2 when I go to do my multiply. So this is a 10 times positive 2, which would result in a positive 20. Since our result is positive, I'm going to put a plus and then our value 20. If our result was a negative, I would put a subtract with a 20 there. All right, and then once I got here, I would say, oh, those are things I could still put together. I can keep simplifying. I can add those up. So 40 plus 20 would give us a resulting number of 60. And it's 2 equivalent methods to get to the same final result. All right, so we're going to start with numerical expressions, which is similar to these. And then we're going to look at some algebraic expressions, which is a little bit different in approach. All right, so we want to expand, not evaluate here. We're going to expand using our distributive property, which says we take our outside multiply item and we hand it out to the items on the inside. So as long as this is a times out here and this is an add or subtract in here, we can take that outside thing and multiply it with the two inside items. So this becomes a 3 times 5, which would give us a 15. And this is a 3 times, remember that's a positive 4 in our brain right now. So 3 times positive 4 would give us a positive 12. A positive is going to look like a plus down here, and then our number of 12. And then once we get here, we would say, are we stuck or can we keep going? Well, those are just numbers we can add up. We're not stuck, so we can keep going. So 15 plus 12 more would give us a grand total here of 27. And it's the same exact result that we would have gotten if it just said evaluate, and we would have followed, please excuse my dear Aunt Sally. All right, number 2, we want to expand using our distributive property. So as long as I have a multiply out here and an add or subtract in here, we can take that outside item and share it to everything on the inside. So this is a negative 2 times 3, which would give us a negative 6. Now be careful here. Remember, you have to think of this as being a negative 1 for a second. All right, so we have negative 2 times negative 1. A negative times a negative is still going to give us a positive, in this case a positive 2, which is going to look like this, plus 2 down here. All right, from there we want to keep going. We're not stuck. Those are numbers we could still put together. So negative 6 plus 2 would give us a negative 4. And it would give us the same exact result as if we had followed the order of operations. All right, nothing changes because we have rational numbers, in this case a fraction on the outside, right? It's a times here and an add here. So we can take this and share it to everything on the inside. So 2/3 times a negative 6 would just give us a negative 4. All right, from here, remember this plus sign, we have to think about it as being positive 15 for a second. So 2/3 times a positive 15 would give us a positive 10. All right, from here, we say, can I keep going? Can I get a better answer? Can I simplify a little bit further, or am I stuck at this one? And we say these are just numbers that we could put together. So negative 4 plus 10 will give us a positive 6. And it's the same result as if we had followed the order of operations. All right, the distributive property, there doesn't have to be 2 items in here. There could be 3 or 4 or 5 or 200. The rule doesn't change. As long as it's a times on the outside and adds and subtracts on the inside, we can take that outside thing and share it to everything on the inside. So let's look at one that's a little bit bigger. In this case, we have a 1, a negative 3, and a positive 5. And we need to take that outside multiply negative 4 times and distribute or share it to everything on the inside. So negative 4 times 1 would just give us a negative 4. Now be careful here. This is a negative 4 being multiplied with a negative 3. A negative times a negative is going to give us a positive, which down here is going to look like a plus. And in this case, a positive 12. All right, negative 4 times positive 5 will give us a negative, which down here will look like a subtract. And in this case, 20. All right, from here we would say, am I stuck? Or can I do a little bit more to see if I can write it in a more basic, simplified version? And since these are all numbers, we can keep going. And more specifically, we can work from left to right until we're completely done. So negative 4 plus 12 would give us an 8. And then we still have our subtract 20. And then 8 minus 20 would just give us a negative 12. All right, you hit pause here. You try the last 2 in your packet. Hopefully you've done your 2 extra problems. For number 5, we're distributing a negative 1/2. We would get a negative 5 plus positive 1, which would give us a negative 4. Be careful with your sign here. Negative times this negative would give you a plus or a positive down below. All right, number 6. We're taking a 9 and sharing it. We'll get a 36 minus 27 plus 45. And then we can simplify by working left to right until we get down to that 54. So here's my question. If these 2 methods get us to the same exact result, why do we even need the distributive property, right? And so you're saying, why wouldn't I just always follow order of operations like you were telling us to do over the last couple weeks, Ms. Howell? You said, if it's a numerical expression, it doesn't matter the instructions, it is always follow order of operations. And now I'm saying, well, you could do this expand using the distributive property also. So here's why we actually have the distributive property. It's not all that helpful when we have a numerical expression, because we could just do, please excuse my dear Aunt Sally, and life is pretty simple. It's when we have variable expressions that we need this distributive property sometimes. And so this problem would look different. It would have something like a 4x plus 2 inside of there, which is different than if it was just a 4. And the reason is these items, this item that has an x and this one that doesn't, they're not like terms, so we can't put them together. And if we went to follow order of operations, we said, do the parentheses parts first. And we say, but wait, we have something with an x and something without an x, and I'm stuck. I can't do the inside of the parentheses. So the only way to get rid of them would be to expand using the distributive property. So let's look at some that include some variables. This is when it's going to be really important for us. So take a second, fill in your important blanks, hit pause here if you need to, fill those in. All right, when expanding, when you have a variable expression, you have to remember the rule that you can only combine things that are like terms. All right, things that are like terms. There's 2 rules that help you establish if something is a like term with something else. Rule number 1, does that term have the same variable part as another term? And by same variable part, we mean it has the same letter, and on that letter it has the same power or exponent, so be careful. And then the other test would be, is it just a number with no variable at all? Because if it's just a number with no variable at all, it's like terms with every other just number. Positives and negatives, decimals, fractions, as long as it's just a number, it goes in a category with other things that are just numbers. So if I gave you this and said, identify the terms below that are like terms with 16y. Remember, we're looking for things that have the same exact variable part as 16y. So the variable part here is really a y to the first power. So we're looking for other terms that have a y to the first, not y squared, not y cubed. It has to have y to the first. If it has a y to the first, we could combine them, we could put them together, we could add them up. If not, they would have to stay separate and they can't be combined with one another. So in this case, this negative y or negative 1y, it's a like term because it has a y to the first power. This y to the third term, 4 times y to the third, is not a like term because it doesn't have y to the first. It has y cubed, so be careful. Same thing down here. This negative 4 times y squared is not a like term because it doesn't have y to the first. It has y squared, right? That one's out. This one over here, again, has a y squared. It would be out. This one is a y to the first. It's a good one. It's a like term. Now, all the others, this has an x, that's out, right? That has an x, it's out. These are just the numbers, they're out. And these have x squared and x cubed, those are out. They have to have the same letter to the same power to be in the same group of like terms, so be careful. All right, so if we say, identify all the terms below that are like terms with negative 9. Negative 9 is just a number with no variable at all. It goes with any other just number. Positives, negatives, fractions, decimals, as long as there's no letter, it goes with this negative 9. So negative 3 would work, 16 would work, 5 would work in this case. All others have some type of variable going on, and they would not be part of this group with negative 9, so be careful. All right, identify the like terms below with just x. Now, x by itself is really a 1 times x to the first. That's what's really there. So we're looking for any other term down below that has an x to the first power. Out, this is x squared, this is x to the third, these are just numbers, this is a y, this is a y, this is a y, this has an x to the first, it's a good one. This is y squared, y to the first, this has an x to the first. So in this list, 9x and 15x are the only ones that would go with 1x to the first power. All right, we have to remember this when we go to distribute. Once we share that outside item to the stuff on the inside, we can only go further with the simplifying process if the things left over are like terms. So be careful. So example number 1, we want to expand that expression using our distributive property. All right, so out here we have a 13 times that's going to get shared with these items on the inside. A variable by itself is really one of that letters, right? This is a 1W inside of there. All right, so we're going to take 13 and multiply it with the stuff on the inside. So 13 times 1 times W, right? This is one big multiply. All right, 13 times a 1 times a W, which will give us a 13 times W, which looks like that. So, all right, we're halfway done. We have to take that outside thing now and share it to the other inside item, which is the 5. So 13 times 5, and in this case, positive 5, which will give us a positive, or a plus, in this case, 65. All right, once we get here, we have to say, can we keep going and put those items together because they're like terms? All right, this one is a W. This one does not, which means they are not like terms. So we can't take those two things and put them together. We are done. All right, number 2, we want to expand using our distributive property. Our outside thing is actually back here for this one. It's the negative 10 times. It's the thing by itself that's being multiplied. We want to share that with everything on the inside. All right, so starting here, negative 10 times 15 would give us a negative 150. Now be careful, this is a negative 4 times t on the inside. All right, so negative 10 times negative 4 times a t. We want to put all that together. So negative times negative is a positive, which will look like a plus. 10 times 4 is a 40, and a 40 being multiplied with t is still a 40 times t, which looks like this. All right, once we get here, this is just a number. This has a t. They are not like terms. Don't go any further. You're stuck there. Good fun. All right, number 3, we want to expand using our distributive property. 1/2 times 4h plus 6. We're taking this 1/2 and we're sharing it with the items on the inside. All right, 1/2 times 4 times h. 1/2 times 4 is 2 times an h still would be 2h. All right, 1/2 times positive 6. Now we're multiplying this whole thing here. So 1/2 times positive 6 will give us a positive 3, which will be a plus 3 down here. All right, 1 has an h. 1 is just a number. They are not like terms. We're stuck. Good final simplified version. All right, number 4, we want to expand using our distributive property. Negative 1/3 times negative 3w minus 12. All right, we'll take this. We're going to multiply here. A negative times a negative here is going to give us a positive, in this case, a positive 1. So negative 1/3 times negative 3 is positive 1 times w, which we can write just as a w, or we could put as a 1w. Those are exactly the same. A letter with no number in front of it is actually a 1. All right, and then we're going to share here. This is negative 1/3 times negative 12. So a negative times a negative will give us a positive, which will look like a plus down here. And then our 1/3 times 12 would give us a positive 4. All right, this has a variable. This one does not. So they are not like terms, so we can't go any further than that. Good final, w plus 4. All right, number 5. We want to take 5j plus 6u times a negative 8. All right, negative 8 times is our outside thing that needs to get distributed or shared to all the items on the inside. So negative 8 times 5 times j would give us a negative 40 times j. All right, we got to do that same thing. A negative 8 times positive 6u. All right, negative times a positive is a negative, which would look like just a subtraction down here. A negative 8 times a positive 6 would give us a negative 48, and then still being multiplied with u. All right, be careful here. To be able to put those together, they have to have identical variable parts. This has a j. This has a u. They don't match perfectly, so they can't go together. Even though they both have a exponent or power of 1, they're not identical letters, and they have to stay separate. We can't simplify any further than that. All right, number 6, a little bit different, a little bit more complex here. In this case, we have a variable on the outside and a variable on the inside, so you have to be extra careful. I'm going to make a little scratch section here. You don't have to show this, but this is what's happening, and it might be helpful on a piece of scratch paper to do when we have complex things going on like this with our variables. All right, so it's this entire thing times this stuff on the inside when we go to expand using our distributive property. So that first problem is a -2, a 4, and then 2 separate m's being multiplied. All right, we have to put all that together into one individual term once we're done multiplying. So -2 times 4 would give us a -8. That takes care of the number portion. And then we have an m times an m. If these were our factors, m times m, and we wanted to write it better as a power, we would say that that becomes m squared, or m to the second power, right? We need that whole thing. -2 times 4, and then 2 separate m's. All right, now we got to repeat that process with the -2m times -3. We have a -2, a -3, and an m still. I promise people are going to do a really good job here putting m squared and then totally forget the m back here. All right, so -2 times m times -3 will give us a positive 6 with m. All right, a negative times negative here will give us a positive. Now, here's where you need to be careful. We can only keep going if those match identically. This has m squared. This has m to the first. So they don't match identically. They are not like terms. Can't go any further. Good final there. All right. Just like with our numerical expressions, the distributive property says as long as we have something being multiplied on the outside and stuff being added and subtracted on the inside, we take that outside thing and share it to everything on the inside. So in this case, there's 3 items, 12a, 6b, and -4, that we have to share that 4 times with when we expand using our distributive property. All right, so 4 times 12a, 4 times 6b, and 4 times -4 to get our expanded version. All right, 4 times 12a would just give us a 48a. 4 times 6b would just give us a 24b, a positive 24b. And then 4 times -4 would give us a -16. All right, to be able to simplify any further, some of these would have to match up. This has an A, this has a B, this is just a number. They are not like terms. That is as far as we can go. It is simplified as possible. All right, last two. We want to expand using our distributive property. We have a -8 times 3m times -5c and times +7. All right, -8 times 3m would give us a -24 times m. Be careful here. A negative times a negative will give us a positive. So down here, it's going to look like a plus. So -8 times -5c would give us a positive or plus 4c. And then back here, a negative times a positive would look like a negative or subtract. In this case, subtract 56. Again, this has an m, this has a c, and this is just a number, which none of our like terms, so we have to keep those all separate from one another. All right, last one. In this case, we have an outside item of -3 times. It has to get shared to 4 inside items, so be careful. All right, start way down here. We will always want to share to what's first in there. So -3 times a 5g would give us a -15g. Now be careful, this next number, -2h. So -3 times a -2h. A negative times a negative is a positive, in this case 6h. All right, -3 times 7y would give us a negative or subtract 21y. And then -3, again, this is a -4s. So negative times negative is a positive 12s. G, H, Y, S, none of them are identical. So nothing left to simplify. Good final expanded version. All right, I hope this helps you attack your work for today. See you guys later.